Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to actually implement whatever the assertions or whatever the constructs or whatever the functions we have discussed in our SV assertions. Okay, so we will start implementing these functions starting from $rows. We will start implementing those. Okay, and followed by $fill. Okay, and $stable, $changed. Okay, these functions, first let us try to implement them and let us check how they are working. So first let us start with $rows. Now before that we will draw a simple clock for this, and this is our clock. So this is at the second edge of clock. My signal is becoming 1, and the third, 4 and 5. Here also it is becoming 1, and let's say this is 6, 7. Let's say our signal is becoming 1 again and 0. Okay, now so this is our sequence we need to check for. Okay, so what is the sequence we are going to write is sequence. So what is the sequence we are going to write is sequence seq at passage of clock $rows of a. This is the checking we need to do. Okay, for every passage of clock, whether our sequence is getting passed or failed, we need to check it out. Okay, so before that we need to generate a clock. So what I am going to do is I am going to generate a clock with 10 nanosecond time period. So always #5 clock is equal to not of clock. So this is my 0 nanosecond, and this is 5 nanosecond, and this is 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 70. Okay, so using this I'm going to first generate this waveform, and then I'm going to write down my assertion. Let's see how. So I'm going to use Vivado tool for this. So first I'm going to create a project, create file, and here I'm going to select SystemVerilog, and here I'm going to write rows function checking, rows function checking, and press OK for this, and next, and just simply finish. So I've created a project for this. So I'm creating a project in my Vivado tool for this assertion checking, and press simply OK and press yes. Now I will open this assertion checking module. Now here I'm going to first of all declare the variables reg clock reset. Okay, no need of reset, just simply reg clock and a. Okay, and I will generate the clock. So how to generate this clock? Always #5 clock is equal to not of clock. So I've generated this clock pulse. I've generated this clock pulse. Now, so within an initial beginning block, what I'm going to do is, so before that I'm going to assign them to 0 initial begin clock comma a is equal to 0. Okay, now within an initial beginning block, what I'm going to do is followed by end. So my a will be equal to 1 after 15 time units. So I will write down that one. So #15 my a is equal to 1, and after 10 time units my a value is becoming 0. So I will write down that one only. #10 a is equal to 0. Okay, next, after 5, 10, 15, 20 time units my a value will become 1 again. After 20 time units my a value is equal to 1, and after 5, 10 time units my a value is becoming 0 again. A value is equal to 0, and after 5 time units again it is becoming 1. After 5 time units a value is equal to 1, and after again 5 time units it is becoming 0. So this is the assertion which I have written and followed by end. Okay. Now here I am going to declare a property. So what is meant by property? Everything we have declared in our previous sessions. If you haven't watched those particular videos, I recommend you to watch those. So I'm declaring a property and this property name. So before that, I will declare a sequence seq1. In this sequence, what I'm going to write is @posage of clock. You can use sequence, or if you want, you can also skip sequence. You can write down the sequence directly inside the property only. No issue in that. Dollar rows of A. Okay. End sequence. This is a sequence which I have written. Now I will declare a property. Let's say the name of the property is PPT. And inside this property, I'm going to check for this sequence seq1 and followed by end property. So this is a property. Now assert property PPT. If this property passes, we are going to display assertion passed. Else, we are going to report an error, assertion failed. Okay, yes. So this is what we have written here. Now let's check whether what is working. So let me simulate it. Yes, first of all, let's check for our this signals what we have generated. Let's check this. So here we can see our A is becoming 1 at 15 nanosecond. That is what we are getting. And at 20 nanosecond, it is becoming 0. And at 45 nanosecond, it should become 1. Yes. And next 55 nanosecond, it should become 0. Okay. And here at 60 nanoseconds, it should become 1 and 0. This is our waveform. Now, at this point, our assertion should fail. And at this point also, our assertion should fail. That is, at 5 nanosecond, our assertion should fail. And at 10 nanosecond also, our assertion should fail. Okay. Why it should fail? That we have already discussed when we are discussing about dollar rows function. Okay. Now let us check it. So these are the messages we are getting in the console. Let me show you what is happening. So we can see at time 5 nanosecond assertion is failed. That is, at 5 nanosecond we are getting the first posage rate and the assertion is failing. And at 10 nanosecond also and at 15 nanosecond also assertion is going to fail. Okay. Next at 25 nanosecond we are getting one more posage of clock and our assertion is also getting failed again. And at 25 nanosecond our assertion is getting pass, and at let's say 35 nanosecond our assertion we will get fail message only. Yes, and here we can see the assertion is getting failed, and at 45 nanosecond we are getting assertion pass message. Sorry, at 45 nanosecond we should get assertion fail message, and at 55 nanosecond we should get assertion pass message. Yes, and at 65 nanosecond we are getting our assertion pass message again, and at 65 nanosecond we will get assertion fail message, and at 75 nanoseconds so on we will get all fail messages only. So this is how we are going to write down our assertions using Vivado tool, and we can check for their behavior. Yes, so that's all about this particular video. If you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching.